Okay, hello everybody. Last step. Again, I recommend that you in general evaluate your university. And second one, because I see some new faces within the lecture, please evaluate also my lecture here. And then let's do the rest of the exercises. Yesterday we ended with the calculation that we first of all had supposed that the marginal rate of consumption is increasing from 70 to 90%. This means this translates in a flatter IS curve, so an increase of overall equilibrium income. And then we asked, this I did in red, if the marginal rate of consumption would be still 70%, how much would we have to increase the government expenditure in order to achieve the same increase of total income? So graphically, this would mean, given still the same LM curve, by how much we have to shift outward the IS curve due to an increase of government expenditure. And in the end, we calculated that we need government expenditure of a value of 110. We started with G is 40, so an increase of 70 would increase also the overall income, starting from roughly 260 to our other value 350. Okay, and then I also need my Excel file in a minute. Is it opening? Here it is. So, and now we asked for a qualitatively similar question that now we again want to achieve this increase from 260 to 350, but now this increase should be a response of an increase of the monetary aggregate. So this means graphically, now we still have the same IS curve as a starting point, and now to shift downward the LM curve in order to achieve here again the same increase of total income. Okay? So what we then need is the old IS curve. This was where we have it here. Where is it? Here is this one, the old IS curve, and now the LM curve, but not inserting the 80 because we want to calculate this new monetary aggregate. So here we have to insert for this 80 variable the nominal monetary aggregate. So then monetary policy. Then the IS curve was y equals 1900 over 3 minus 100 and times I. And the LM curve in our case now would be 3 times y minus 200. I equals now m over 4. This was 3y minus 200, was it? Or yep, 200i now equals m over 4. And the question is then now, what is m if y equals y star, and this was 350.91. So now I choose another way compared to yesterday. This is maybe a more direct way compared to this, what we have done yesterday. Yesterday I went through all the equilibrium calculation, but quite often there are different ways how we can achieve what we want to have. So we mentioned that still the old IS curve is valid. And we know what kind of income we want to achieve. So this means we can insert into the IS curve the new income. And since the IS curve is valid, we then can directly calculate from the IS curve the new interest rate. Yeah. Then we obtain the new interest rate. And with this together, we can now step into the LM curve, because again, we want to have the given income. We know from the IS curve the corresponding interest rate. This we can also insert. And then you see we are only left with the last variable m, and so we can calculate m. Okay, so this is a more direct way to do it. So this means then we have our 350.91 equals 1000 over 3 minus 100i. This we solve for I. So we obtain 100i equals over 3 minus 350.9. So our I star will be 1 over 100 times over 3 minus 350.91 over 100. So then let's calculate this. Yep. You can all see this, everybody. So we obtain is 19 over 3 minus 350 over 100 is 2.82. So and if you are doing this calculation, you always should think about, well, is my outcome reasonable? Is it okay? And for this, I recommend that you always have this graphical interpretation in mind. And we know we are moving here, starting from the starting equilibrium point, now downwards the IS curve, so down to here. And this means we have to obtain a lower interest rate. It should be a little bit lower than our starting interest rate. The starting interest rate was 3.76. Now we have 2.82, so it is a quite reasonable outcome. Yeah. So, and now we have I star, we have Y star, and these two we just insert into our LM curve. So insert Y star and I star into LM. This means 3 times 350.91 minus 200 times 2.82 is m over 4. So m equals 4 times 350.91 minus 200 times 2.82. So this will be then 3 times our 350 minus 200 times the new one times 4. So this is, oops, 1951 roughly. And in the German course this morning, I was a little bit surprised when I've calculated this quite large number for M. Yeah. Well, we know that it has to be larger than our starting value. We came from 80. But roughly 2000 is much larger than 80. So at the first step, I thought, well, maybe I have done something wrong. But of course, the direction is correct. And then, yeah, maybe you go purely technically through your calculations. Is it wrong or not? And then you can achieve the right result. Or you can also have a look at the given functions. If you, so to speak, can qualitatively explain why it is such a huge increase. And then if you go into your starting calculation here, then where it is, yeah, if you then take the equation for the LM curve, then you see your starting equilibrium income level 250 times 3. This is roughly 750. And then time minus 200 times I. 200, I was 3.7. So these two numbers here are quite in the neighborhood. And from this, then we achieve on the right-hand side a quite low number, so to speak, because this number and this number are quite close. But now we are increasing our y, and we know that this means that we have to decrease I. So we get a split of these two numbers. And then we see that relatively the, so to speak, interest rate intensity of money demand with a factor of 200 is quite high compared to the income intensity, which is only 3. And this means only a slight increase of y means that we obtain a quite large split of these two numbers. Because here the interest rate intensity is much higher than the income intensity in money demand. And if you then have the look at this, okay, this huge increase of M from 80 to 1,950, this is also reasonable. And in the end, we would then obtain delta M is roughly 1,951 minus our 80. And this is then roughly 1,871, I think. Hopefully I've done it right. Okay, so that's it. And the last one is, let's take orange now, that we now want to go to the ASAD model, and we have given our IS equation. So last one, C, ASAD model. And again, I think it is a good idea that we know graphically what happens now. Well, within the ASID model, we had y, our AS curve, and falling AD curve, and now the overall equilibrium would be just the cut between the aggregate demand and aggregate supply curve. Well, AS we have given directly in our exercise, P equals y over 100. And the AIS curve we have derived in our lecture from the ISLM model, now with flexible prices. And prices in the LM curve we had here. Within our exercise at the starting point, we had this fixed price level of 4, and now it is flexible. So what we now need is still our old IS curve, because in the IS curve we do not have any price. And now we have to write down the condition from the money market for the LM curve, now with flexible prices with a variable P. Okay? So, oops. This would that mean we need IS still, this one. Y is 1 minus 100A. And for the LM curve, now we have this one, now with M is 80, our initial value, but not P equal to 4, but only the variable P. Okay? So 3 times Y minus 200I equals M, oh, not M, sorry, 80 over P. Okay, in the end, we want to have only the dependence between prices and income. Here, we have still our dependence on I. So what we then do is, again, you have different ways to do it. You can solve both equations for I and equating these two equations, or solving one of these equations for I and putting it into the other one. So in this case, let's say solve this for I. Then we obtain 200 I equals 80 over P minus, minus 3 times Y. So I is 1 over 200, or 80 over 200, 1 over P minus 3 over 200. I think I missed the signs, or it's this has to be minus and this has to be plus. Sorry for this. 3 over 200 y. So this cancels, and divided by 4 is 2 over 5. So let's write down it here. So we obtain I is 3 over 200 y minus 2 over 5 times 1 over p. Well, and this now we can insert into IS. Insert into IS. So then we have y equals over 3 minus 100. And now inserting this, oh, this y has to be up here. 3 over 200 times y minus 2 over 5, 1 over p. So then we have 1900 over 3 minus 3 over 2 times y plus 100 over 5 is 20. 2 times 20 is 40. So 40 times 1 over p. Okay? And now we solve this for y. So then we have y times 1 plus 3 over 2 equals over 3 plus 40 times 1 over p. This is 5 over 2. So we obtain y equals, oops, 2 over 5 times 1900 over 3 plus 2 over 5 times 40 times 1 over p. So this is 8. 2 times 8 is 16. And what is 1900 over 5? Is 1900 over 5. 380, 760 over 3 then, yeah? Plus 16, 1 over p. And this would be then our AD curve. In order to obtain the overall equilibrium, what we have to do? Pardon? Yes, here we have AS, so we just insert, for example, AS into AD. So inserting AS is then Y equals 760 over 3 times 16 times 1 over Y over 100. Oops, and this is a plus here. And this is then Y equals 760 over 3 plus, and this is 1600 over Y. 1600 over Y. This we have to solve for Y. What are we doing? Well, multiplying with Y, we obtain Y squared minus 760 over 3Y minus 1600 equals 0. And now, yes, what kind of equation this is? This is just a quadratic equation. Class 9, I think, roughly, there you have learned how to solve quadratic equations. Well, but we are in a digital world, and I have an AI models here. So I would say just solve Y squared minus 760 times Y over 3 minus 1600 equals 0. So this is then my solution. Of course, I have a quadratic equation, so I obtain two solutions. Which one would be reasonable? The positive one, of course. So solve this and we obtain y star is roughly what have we? 259.5. 259.5. How do we obtain our equilibrium price? Yes, here, for example, this would be the easiest one just in the IS coefficient. So this would be then 259.5 over 100 is roughly 2.6. Okay, that's it. And I think I asked for graphics. No, but since this was asked this morning, then if I ask you, provide a little diagram, then in this case, since we have the definite functions, then this would mean that I do not only want the general sketch, but that you roughly look at what kind of functions do I have and then sketch this. So in this case, we know for the IS curve, well, this I have already drawn here, roughly this is just the linear line starting in the origin. Yeah. So then in this case, if you should sketch the overall equilibrium, please draw then also a linear line starting in the origin and not somewhere else. And the AD curve, this we have here. And there you see, I have here a constant part. And this is a function which is just a constant over p. So it is just f of x equals 1 over x. And from this we know it is in general a hyperbola. And since we add a constant part, it is just a hyperbola shifted to the right. So then maybe you put in this one. This would be your 760 over 3, and our AD curve would then look like this. And then I'm fine. Well, you can also, of course, give the data into Excel, and then you can directly plot your functions or use some other software, mathematical software package. There you also obtain, of course, the diagrams and then copy it and paste it into your little term paper. This is also okay. But if you reasonably sketch it by hand, then it's also okay for me. Yeah, that you know what I mean when I ask for a diagram. Okay, and then let's move to the neoclassical part. The labor market. You should calculate, first of all, labor supply from consumption spare time decision and labor demand from profit maximization. And in this case, I explicitly gave you a utility function, I gave you explicitly a production function, and the time budget of the consumers. So let's copy this one. Oops, this one, this one. So let's start with labor supply from consumption spare time decision. What was this in general? We have to maximize utility depending on spare time F and consumption C, subject to our budget restriction. Our budget restriction means we have a budget of time which is set to 1 in general, so L bar equals our spare time F plus our labor time L. And the other restriction was that all our labor income we are spending for consumption. This means W L equals P times C. So this is labor income and consumption. Now we have two restrictions, and then I said to you, well, we can solve this for L is L times P over W times C, and inserting this into the time restriction, we obtain L bar equals F plus, and I also recommend to calculate the dependencies with respect to real wage. So let's define omega is W over P, and this is real wage. So 1 over omega times C. So, and now we have the explicit functions and our time restriction. So what we have to do is maximize U equals C plus 2 times square root of F, subject to 1 equals 1 times F plus 1 over omega times C. And I use this representation that you also hopefully can recognize that it is totally similar to the household optimizing problem which you have done in microeconomics. What we have to do now is consumption spare time. Maximum spare time is 1, sitting the whole day at the beach, or working the whole day. Then I have a labor income of omega times 1, so omega. This would be then my budget restriction. And then I have to look for the optimal indifference curve. And this would be my optimum. And what is the condition in the optimum? I'm interested into this spare time optimum, and then I know that 1 is optimal spare time plus optimum labor time. So optimum labor time is 1 minus F star. And this would be then my labor supply. But what is the condition here? Well, you can see it also in the diagram graphically. The slopes of the two curves have to coincide. Okay? Slope of budget line equals slope of indifference curve. And this you have called in microeconomics marginal rate of substitution equals price ratio. So this is the problem graphically that you hopefully can remember it from microeconomics. And how do we have to do it technically? This. There are different ways. Which solution techniques do you know? I will only choose one here. You should know at least three. Yeah? What do you mean by dividing one? Pardon? Yes. How do you, if you want to calculate the marginal rate of substitution? There you are calculating a ratio, but it is a specific ratio. Yeah, for sure. This is qualitatively formulated, but here I have explicit functions. So you have to you have to answer me, what do I have to calculate? So this is one. I calculate the slope of the budget line, and I calculate the slope of the indifference curve, marginal rate of substitution. This is one possibility. Another such solution method. What can I also do? Lagrangian multiplier, or I don't know how you have called it, maybe insertion method, that you solve for one variable your budget restriction and then insert this into the utility function, and then you have only a function depending on one variable, and this you can maximize with just deriving with respect to your variable. So this morning I did it with the direct method, marginal rate of substitution. Let's do it now with another one. Let's do it with the Lagrangian multiplier method. What would be your Lagrange function? Now depending on spare time, consumption, and your Lagrangian multiplier. It's a pity, but I'm talking to my colleagues, and I know that this is one of the core topics in microeconomics. This you have done quite often. Also with explicit functions, and also I know that he is also using a function like this, which is called quasi-linear, because it is here as this linear part in one variable. This is also a quite nice function for you, because this means that the derivative with respect to consumption is quite easy. So how does it look like? Well, it is just the utility function c plus 2 square root of f plus Lagrangian multiplier times now reformulated the restriction such that the restriction is just 0. This I always call, this is a general trick in mathematics, adding a special 0 or multiplying with a special 1. Because this doesn't change the value of a utility. This is a trick behind it. So this would be then 1 minus f minus 1 over omega times c. This is just reformulated this budget restriction, and I know that this is 0. In order to optimize this, what do I have to do with this function? Pardon? Yeah, in the end, but the starting point. Yeah. Yeah, we take the derivatives with respect to all variables. So first of all, dl with respect to EDF, this would be, yeah, for sure. Yeah. Well, it doesn't matter for the outcome. You can add it with a plus or you can subtract it with a minus. Well, in our case, the reason for this is because our utility function has the property that the more is better always. Yeah, this is one of the core assumptions which you make for utility or for preferences. Well, I think in microeconomics you have also talked about it. If the 17th ball of ice, there is no adding, there is no further utility from this, or even if it's worse. But in general, we assume the more the better, and this means we are always using our full budget. Yeah. But I think about the reasons of this you have talked in microeconomics, general utility theory. So, but here we have just to take the technically the the derivative with respect to spare time, f. So for this you have to know what is the derivative of f of x equals square root of x. F of x, square root of x, what is f prime? Hmm? Minus? Yeah. Power of? Yes. Which power? Let's see if the internet, oh, I haven't opened the chat. Maybe there's an answer. What is the derivative of square root? Mm-hmm. Yes, 1 over 2 times square root of x. Yeah, that's it. So then we see that this 2 cancels with this 2. What is derivative with respect to f of c? Not 1. 0, of course. It's just a constant if you taking the derivative with respect to the other variable. So we obtain 1 over square root of f, and then we have also to take the derivative of the restriction with respect to f. No. Well, you have here f. This is your variable. So yes, it's minus lambda. So f of x equals x, and then the derivative is just 1. So you have lambda times f, and you are left just with the lambda, and you of course you have here your minus sign. So minus lambda equals 0. Then we need dl with respect to c. Yes, 1 minus, yes, 1 over omega times lambda equals 0. Well, and the derivative with respect to lambda, well, this is totally easy because we have constructed it that we just obtain the restriction. So 1 minus f minus 1 over omega times c equals 0. Then hopefully this has been shown to you that there is, since this is a nonlinear system of equations, that in general it would be just a good idea to solve both sides for the prices or for the this part here, and then you obtain 1 over f equals lambda, and we obtain 1 is lambda over omega. Now you could say, well, lambda is omega, and inserting it in the first equation, or, and this works always, you just divide both sides, because then you also get rid of the lambda. That you here can directly solve this equation for lambda and inserting it. This is due to our very easy function. If I give you another function, then it would be more complicated. But so to speak, the trick to divide both equations through each other, this works always to get rid of the lambda. So then we obtain 1 over square root of f equals lambda over omega. The lambda cancels. This is because this is the reason why we are doing it. So I have 1 over omega. So the omega then will appear just upward. Okay. And this then means that we obtain f equals 1 over omega squared. But we are not interested in the spare time. We are interested into the labor time. So labor demand function depending on omega is 1 minus 1 over omega squared. This is labor demand. So now, sorry, not labor demand, labor supply, of course. Well, in this case, if you remember the lecture, then I said, well, in general, the dependence, if if labor is increasing or decreasing with respect to the wage rate, this is not clear because we have to know, is the income effect or the substitution effect larger? Well, since I want here, so to speak, yeah, normal situation, for this, it should be increasing, that the supply function is increasing in prices. And if you then have a look at this function here, then you know, okay, 1 over x squared, this is first of all a falling function, but then I have the minus, and I'm subtracting it from a constant. So this means overall it is an increasing function. Then let's go to, oh, there was a question. Oh, sorry, yeah, this is of course S. Thank you very much for this. So then let's go to the profit maximization. There are some words in German which are internationally valid. The one is kindergarten, and the other one is in mathematics, the Ansatz. So what I then also want to see from you in the next week is that you write down me, hopefully, the right Ansatz. So that I can see, well, your starting point is okay. So to speak here, and this was also in part A, my question, what is the maximization problem here for labor supply? And this then would be, I want to see something like this. Then you have analytically formulated what you have to do. And if then you miscalculated something, okay, not 100% of points, but still I see the starting point is okay. The economics behind you have understood. And so here I also want to know, well, in general, profit maximization, what does it mean now if I have here my explicit functions given? So what is profit in general? Yes, revenue minus cost. I think in almost every lecture you hear this. So, and now you have to translate this into this explicit exercise here. So, profit, quite often we take a pi. And what is now revenue in my explicit example? Almost. Not only output, revenue is not output, but revenue is, one part is output and the other part price. Price times quantity, so P times Y. And what are the costs in my example? Labor. And what is labor cost explicitly? Wage times labor time. Yeah. So omega times L. And I have another part because I have two inputs. Capital, and the price of capital is not P. Well, I, yes, plus I times K, or if you use, since I haven't provided, oh yeah, here I have provided the I. So this is the cost. Well, then output is explicitly given. So I have profit equals P times 2 times square root of K and L minus WL plus IK. And now from this profit function, I want to derive the labor demand. So I have to focus on the variable L. Yeah. So this is then a function of labor. This is what I want to do now. I don't care about the capital. This is just a fixed input. Suppose K is fixed. So, and this I want to maximize now. What I have to do technically in order to maximize a function. Yep, taking the derivative, of course. And now the derivative with respect to L only. Yeah, pardon? In the end, that you really have a maximum, then in general, you always also have to take the second derivative, inserting your 0 point of the first derivative, and then looking, is this minus, so I have a maximum. Well, okay, in this case, I say in general, we see here we have positive but decreasing marginal products. So I know it is a right banded function. And this I gave you also in the lecture when I had here, what can we do? We can do here revenue and costs. And this is your cost function, L omega times L. And we have this right banded production function. This is P times Y of L. And what we want to do is to calculate the maximum difference between these two functions. Well, and then actually from the functions, I directly see that it is a maximum. So, and since this is not the microeconomics lecture, but only the macroeconomics lecture, and I know that you have already participated in microeconomics, so I assume that you know, well, if I find an optimum, then I know that it is a maximum. So for me, you do not have to calculate the second derivative and calculating the sign of this derivative, okay? So for me, then it would be okay just taking the derivative with respect to labor. We are in a fully competitive market. This means we have to take the prices as given. And I also said that capital is given. So this is also just a fixed number for us. You can also interpret this as the fixed cost part of your cost function. So what is the derivative? With respect to L. Pardon? Square root of k, of course, this is then. And this is a fixed number, this, so we just can write it down. So 2 times p times square root of k. And what happens to square root of L? This we have done a minute ago. Yep. Yep. So 2 times square root of L, and this 2 here cancels. Then we also have to take the derivative of the cost function. Minus, yep. No, this is not omega, this is W here, yeah? Omega was W over P. So W is nominal wage, and W over P, this is omega, this is real wage. And this has to be 0. So then let me just write it down also like this. P times square root of K square root over L equals W, because then also doing these calculations is not just to annoy you, but what have we here? This is the value of the marginal product of labor. Value of marginal product of labor. And what is this? This is the price of labor. So what, economic reason is behind this equation? Well, the left-hand side is the additional revenue you obtain from your last worker. Yeah? If you hire another person, then you are increasing your output. How much do you increase your output? This is just this derivative times P. So this is the additional revenue a worker is creating. What is the right-hand side? The right-hand side is the cost of this worker. So of course also the additional cost. And when is it profitable to hire a new person? It is then profitable if the left-hand side would be at least as large as the right-hand side, so that the additional revenue is at least as large as the additional cost, because otherwise I would lose something. And since I have assumed this decreasing marginal product, this means the additional revenue starting from the first, second, third person and so on is decreasing. This is this right banded production function. So, and this means I hire people until this point when the last additional worker just creates as much additional revenue as its costs. So in the end, the last worker, for the last worker, I have here this equality sign. Yeah? Let's assume this is the 10th worker. The 11th worker would also create additional revenue, but the additional revenue of the 11th worker would be less than the wage rate. And so I think it is quite reasonable to interpret what we have done here. Okay, so, but then let's solve this for L. Solve for L, then we obtain square root of K over square root of L is now W over P. This we have defined as omega as real wage rate. Yeah, because we have also taken here for labor supply independence of omega. Then multiply by the square root of L means square root of L is square root of K over omega and dividing by omega. And then, of course, taking the square of both sides. I obtain L equals K over omega squared. And this is now my labor demand. Labor demand depending on omega. And here I also see, well, 1 over x squared. This is roughly a hyperbola, so a falling function in the price. Also reasonable. Then labor market equilibrium. What do I have to do in order to calculate the labor market equilibrium? In which function? Well, I have derived this from this here. If you put this function into this function, you will only obtain identity. For the overall equilibrium, what have we always to do? Market equilibrium. We obtain when demand equals supply, or yeah. So Ls of omega equals Ld of omega, and labor supply 1 minus 1 over omega equals K over omega squared. This we have to solve for omega. How do we do this? Does it really cancel? I don't think so. K is just a number. Here we have assumed that it is just a fixed number. So I want to have omega equals 2, and then there would be some numbers, and of course this K. What do you mean by move? Adding, subtracting, multiplying, dividing. This is so you want to add 1 over omega square or what? So both sides plus K over omega squared or what? Yeah, what now? So we have 10 minutes left. Actually, this is class 9. Maybe 8. Yes, of course, multiply with omega squared. Omega squared, this cancels. This is the reason why I do it. Minus 1 is K plus 1. Omega squared is K plus 1. And the last one, square root, of course. Thank you very much. Omega star is square root of K plus 1. What is then L star? Or how do I obtain L star? This is always the same. We have done this the last in the ASAD, ISLM model. We have the first variable. We have two variables. So just insert this into the labor supply or labor demand function. So let's insert this inside here. So I obtain k over square root of k plus 1 squared is k over k plus 1. And here also with a diagram, how can I sketch this labor market equilibrium? So labor demand here, this is roughly 1 over x squared. This looks like also similar to 1 over x. This you should know. So this would be labor demand. Then a little bit more complicated is this one. Yeah. So how looks labor supply of omega equals 1 minus 1 over omega? I already have argued that it is an increasing function, and now I want to know how it does it look like. Well, here I see if omega is 1, then labor supply is 0, okay? 1 minus 1 over 1 squared is 0. So I'm starting then somewhere here. Then I also see if the real wage rate is a really large number, then 1 over a large number is a very small number. Then I know that I reach approximately 1. So this would be then an asymptotic line. Well, and how do I reach asymptotically this 1? Well, it is just again 1 over x squared. So again, it looks like a hyperbola. So this would be then look like this. And this is then L star, and this is omega star. This was square root of k plus 1, and this was k over k plus 1. And that's it. Okay, so we are through. What have we done? Well, tomorrow, when the exam is starting, everybody of you will get a country. Then you should download some data, as I've done it here with you together, maybe over the last 10, 20 years or so. Then you should do some calculation, averaging, calculating the average growth rates, price development or something like this. And then I will maybe ask you also some general question on the business cycle of this country, so that I see that you somehow have read a little bit about your country, but not very much. Maybe half a page or not more. Yeah. Then what else did we do? We did here some explicit calculations where we have here real growth, nominal growth with each other. And if you go through the lecture, there I had also some explicit calculation on inflation, Maybe I put something like this together, but in a way as we have done it here in the exercises and in the lecture. And then I will also, yeah, ask some question about this in general. But you have time, you can look up into your slides in your own things of the lecture, then I think you will make it. And the last one was then that I will ask you something about theory. ISLM model, ASAD, or yes, like we have done it here in the last part about the neoclassical model. So I don't think that there will be a real surprise what I'm going to ask you because you have seen this. Yep. Pardon? What do you mean by? Yeah, for sure. Yeah, for sure. You have to answer it. And then, yeah. So okay, okay. Yeah. Or you should answer it. Hopefully you answer it. Yep. Yeah. Mm, yeah. Yeah. This is only that the uploading mechanism is functioning. No, of course not. No, no. This is only that you can that it is possible for you to upload something, and that it works. Yeah. Nothing else. So anything else? Because otherwise I'm through. Yep. What do you mean? Yeah, for sure. So you will obtain four tasks. Every task will have 25 points. Overall, it's 100. And if there is one where you have more difficulties, well, maybe it's then not a one, but only a two. Yeah, yeah, for sure. This I really recommend that you use some software package or even, of course, Excel. But please be then also careful. You can, as I did it here, you can just paste, copy, and you can make a copy and paste, put it into your file. But please make some annotations that I know what you have calculated. Yeah, handwritten is of course also okay. Yeah. Yep. Everybody gets. You will see it how I make it individual. But everybody gets, and so everybody gets a different country, of course. Then you have to do different things because you have different data, and also every other tasks will be individualized. No, of course not. They will be similar, but they will not be the same. Maybe. So it's an individual term paper. It's no group work. So then, any other questions? 1 minute is left. Yep. This is the last lecture. Yeah. Tomorrow the exam starts. 8 o'clock. Yeah, of course. Then write me an email and then. Because sometimes in my questions I may get a mistake or something. Hopefully not, but I'm also only a human being. Yeah. Mhm. Yeah, for sure. But actually also I always have said within this lecture, if you use software packages, and AI is of course a software package, you have to know what you are doing. And please be careful using artificial intelligence because it is only a probable answer. Yeah? AI is not a mathematical program. If you use Maple, Mathematica, or whatever, and then with this you solve your equations, then you can be sure that the answer is right. MATLAB, of course, yeah, you can use it, yeah, for sure. Well, you can use it because this is also the idea behind this kind of new kind of exam form. Because, well, I really recommend that you start to use all the helpful things we have. You will have to use it later on in the labor market. Yeah. Then you cannot sit there and, give me a week because I have to do it by hand. Then they will look at you, please, we have a digitalized world. Use this. Or as I mentioned it, hopefully in the end, you and the digitalized world, you are complements and not substitutes. This is my idea behind it. Because if later on the enterprise can substitute you with capital, with some software package, this would be not a good situation for you. And somehow, I have to admit, somehow we see it in the labor market in Germany. You see everywhere enterprises asking everywhere, well, come to us, come to us, come to us. We need people, we need people. And we have in Germany, due to our demographic development, a shortage of people. Yeah, we have too less young people in Germany. Therefore, it's really good that you are here. We need you. But we need you also with the right skills. Because what is quite surprising in this situation, that you everywhere see the enterprises, we need you, we need you, we need you. That the unemployment rate is increasing in Germany. And this somehow means that there are some, or right now, maybe even many young people which do not have the skills we need in the labor market. And in my idea, one reason is that you really have to use all these digital helpful things we have right now. Because then you can really reduce the time for your tasks. But you have to know what you are doing. And when you have asked, yeah, you can use AI. But then look at the output. And as I mentioned it here, you look at your result and then just think about, is it reasonable? Okay, the interest rate has decreased. I know the interest rate have to decrease. first task today when we went down the IS curve. Yeah. And this is then one of your skills when you have used a mathematical program or something like this, that you see, okay, the answer is reasonable. And this, on the other hand, is then a hint that the probability that the answer is also right is really, really high. Because otherwise, you get any answer you can think of this. Yeah. Okay. So I say have fun the next week.